Hello everyone and welcome back. My name is Mr. Kowalt, and in this video I'm going to be going over some questions that you should answer before continuing on to your equilibrium question. So when you're presented with an equilibrium question, there's some things you need to pay attention to first before you start to try to solve the problem. Okay, so here I have a little table here to help us organize our thoughts and things to keep in mind when you're looking at an equilibrium problem or equilibrium question. Okay, so first you need to look at the stressor and determine what the stressor is, what's changing in the problem, what change are you making to the system or the reaction, and then answer a question about that. So let's start with the first stressor. So increase or a decrease in the concentration. Remember, these square brackets means concentration of something. So if you're going to increase or decrease the concentration of products or reactants, if that's the situation, then the question you want to ask yourself is this one: which phase is it in? Basically, what is the phase of the substance that I am changing, that I'm increasing or decreasing, right? So then you answer the question. If it's a gas or aqueous, then you change things. Things are going to change. It's either going to shift left or right depending on Le Chatelier's principle, and based on whether you're increasing or decreasing reactants or increasing or decreasing products, right? So if it's a gas or aqueous, things are going to change, so you need to think about how that's going to change. If it's a solid or liquid, where nothing's going to change because the concentrations of solids and liquids are constant. They don't factor into the scenario. They don't factor into the um, the equilibrium of the system or the reaction, right? Precisely because they don't have a concentration that changes, or we can ignore them in the reaction. Okay, so that's the first thing we want to look at. Okay, so the next stressor, that's the first stressor. The second stressor is increase or decrease in temperature. So if the problem or question is indicating that there's a change in temperature, then the question you need to ask yourself is the reaction an endothermic reaction or is it an exothermic reaction? And that's going to be important because if it's exothermic or endothermic, that's going to indicate or going to help you figure out which way Le Chatelier's principle is going to tell you to go, right? So keep in mind that if it's endothermic, that means that energy is being absorbed. It's being taken into the system. So that means that in this case, when you write out your equation or your equilibrium equation for this reaction, the the energy or heat that's being absorbed is going to be on the reactant side of your equation. So in that case, you can treat it like a reactant. And you can treat your temperature change as if that's what you're adding or subtracting from the system, right? So for example, if say it's an endothermic reaction, right? So energy would be a reactant on the reactant side or on the left side of your reaction equilibrium arrow. And so in that case, when you're raising the temperature, that's like adding heat, right? So how do you raise temperature? You put in energy, right? So if you're adding energy to the system by raising the temperature, that's going to indicate that you are increasing reactants in that case, because if it's an endothermic reaction, we're treating heat energy or energy and heat as a reactant on the reactant side. And if you're raising temperature, well, how do you raise temperature? You're adding heat or energy to the system. And so it's going to, if we think of the energy as a reactant on the reactant side, then we can treat it like just like we would treat it with changes in concentration, right? So Le Chatelier's principle would say, well, if I'm increasing the reactants, then Le Chatelier's principle says that the reaction is going to undo that by shifting towards the reactants, shifting towards the products, making more products, and losing the reactants. So you would have a shift in that case towards products, right? Because the heat or energy is a reactant and you're kind of increasing the amount of that reactant. Again, if it's exothermic, then that means that heat's being released, and that means that we can treat the heat as a product. And so we write the energy as a product on the right side of the equilibrium arrow. And so again, we treat that as a product, just like we would treat increase or decrease in concentration. So we would use Le Chatelier's principle the exact same way, right? So if we're raising the temperature, that means we're adding heat to the system. And if heat is or energy is a product, that means we're kind of increasing product. Well, what does Le Chatelier's principle say? It says that it's going to undo that stress. So it's going to try to get rid of that heat, that energy. So it's going to go in the opposite direction. So it's going to shift towards reactants. And then that way it's going to try to absorb some of that heat and get back to equilibrium. And so we're going to have a shift towards the left side of the arrow towards reactants. So we can treat energy as either a product or reactant, depending on whether it's endothermic or exothermic. Okay, and finally, what about increasing or decreasing total pressure, right? So this is very similar to, or is pretty much the same thing as a change in volume or a change in the number of moles of gas. All three of those changes are going to, both of these changes here are going to lead to a change in pressure. If I have a container and I put more gas particles into the container, that's going to increase the pressure in the container because I have more particles bouncing around inside the container. So more particles are going to be hitting up against the side of the container at any moment in time. And so more force, more pressure on the container. And also, if we change the volume, right? If I increase the volume of my container, that means I'm giving the particles more space so that there's going to be more surface area on the inside of the container. And therefore, less particles are going to be hitting up against the inside of the container at any one moment. And so that's going to decrease the force that those particles are applying, and therefore the pressure is going to decrease. So change in volume and change in the number of moles of your gas is going to have the same effect on pressure as just increasing and decreasing the pressure itself in other ways, right? So what happens if we increase or decrease the total pressure? Well, the question we have to ask ourselves in this case is which side of our equation that's in equilibrium has the fewest or most number of the moles of gas, right? So what's the number of moles of gas on each side of the equation? That's our question. And so when we answer that question, then we know that according to Le Chatelier's principle, if we increase pressure, that means there's going to be a shift or move to the side that has fewer moles of gas. Because remember, if we're increasing the pressure, the system is going to want to undo that increase in pressure. So it's going to want to lower the pressure. How does it do that? Decrease the number of particles. So it's going to shift to the side that has the fewer moles of gas particles. And remember, this is gas particles. We're talking about gases here. This is not solid or liquid or aqueous particles, right? So those particles are not going to so much affect the pressure, right? So again, if we're decreasing pressure, then it's the opposite. So if we're decreasing the pressure, the system is going to want to undo that decrease. So it's going to try to increase the pressure. And the way it does that is by shifting towards the side that has more moles of gas. And so that way it's going to increase the number of particles in the gas phase and try to get back to the equilibrium pressure. And again, remember, you're not going to reach the equilibrium that you were at before, the equilibrium state or pressures or concentrations you were at before, but you will get around that area. So close to what you were at before, but not quite exactly the same. Okay. Sorry about that. So that's it for this video. I hope this was helpful. If you enjoyed this video or liked this video or learned something from this video, then please, by all means, share this video with your friends. Hit that like button and also make sure you subscribe to my channel. Hit that notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me. Have a great day.